as usual in our webinars, the first talk is about a project from the OW2 community. So it can be either a project like today, or it can be any kind of initiative related to the community life. And the second talk is related to NGI success stories. So today it is Percors. So just a quick reminder of what was done before in the previous webinar. So the first one was featuring les Monelda PNG project, and Alma, which is a project from the E-Foundation, funded from the E-Foundation, the EOS, the Google smartphones, funded by NGI. And the second was with PrestaShop and Open Food Facts. So now we will start with Leslie on BlueMind. Leslie is the head of communications at BlueMind. She had a career before in marketing, also as marketing manager in aeronautics and in artificial intelligence as well. And now she's more attracted by disseminating and promoting the open source culture. So I think that probably BlueMind is a better vehicle than aeronautics to do so. So I will give the floor to Leslie, and she will tell you more about how to remove Microsoft suites from your systems.
So hi, so I am Leslie Saladin. I'm the marketing manager at BlueMind, and thanks OW2 for this opportunity to introduce you to BlueMind today. So BlueMind is a French company. We are based in Toulouse, just like Airbus. We talked about aeronautics just before. We are the European collaborative email alternative to Microsoft Exchange and O365. So quickly in a glimpse, who are we? We are the first software publisher for corporate emails in Europe. The thing about email is that it looks easy. Nobody really thinks about it. It comes, it goes, it seems natural, just like electricity, just like turning on the lights in your office. But if it stops, the company just can't run anymore, and everything has to stop. So it's very critical, and it's not that easy to do. Actually, it requires a lot of expertise and skill, and that's why there isn't so many players in that game. And today we have more than 600 clients of all shapes and sizes in Europe and Africa. I'll get back to it. We are open source, obviously, and very much involved in that community. Pierre-Yves, who is BlueMind's CEO, is also the co-president of the French lobby for open source advocacy, the CNLL, which stands for Conseil National du Logiciel Libre. Our sales model is indirect. We work with more than 30 integrator partners. Like I said, we have more than 600 clients of all shapes and sizes in Europe and Africa. We are, sorry. Here are some of our clients, corporations, cities of all sizes like Marseille, Villejuif, La Courneuve, and even public departments such as the French Ministry of Foreign Affairs. So why did we create BlueMind? Why would people need BlueMind when there is Microsoft? Well, one of the main reasons is digital sovereignty. This means being able to choose who you're going to work with, not being constrained by technology, whether it's hardware or software. It also means to be in control of your data, knowing where it is, who can access it and use it. And remember that some American laws are extraterritorial, meaning that they apply to your data, even if they are physically stored, hosted in Europe by an American company. And also, digital sovereignty means being safe from legal constraints. Europe is trying to protect itself from predatory companies, mostly from the US, but also more and more from Asia, by taking new votes and directives towards more protectionism. So that being said, how does this affect email? Well, like I said, email is critical. Your company cannot suffer from an email shutdown. So email is high volume and strong flow. I can't remember the figures, but it's billions of emails sent every day in the world. We are okay with changing email systems, but we want to keep Outlook. This one may be the most important. When we talk about email, we are talking about something everyone uses every day with no regard with their position in the company, whether they are the CEO or the youngest intern, the lady at the desk or the gentleman on the phone. So email is strongly dependent on user experience and even more so on user satisfaction. You may want to change and get rid of Microsoft, but the resistance may be so strong that you will end up renewing your Microsoft contract for that sole reason. And we see that every day. I'll get back to it because BlueMind has a solution for that. Last thing at stake with email and digital sovereignty is that email is at the heart of your business data. Everything goes through email. The invitation to this very webinar went through your email. Also your contracts, client intel, prices, you name it. This is an image we like to use. We often use it to illustrate that people are okay to change as long as their daily routine stays the same. And most of the time, when we talk about email, the daily routine is Outlook. They want Outlook, and that's not negotiable. So given all this, how do we, as a French open source software company, propose to replace Microsoft? Well, to do that, we need three things. First, a good product, the ability to switch to that product, and a strong focus on user experience. I will detail all of it. So, good product. Good product means covering the spectrum of all corporate needs in regard of collaborative email. So obviously email, but also calendar, video conferencing, tasks, chat, drive. We can also be the email part of your digital workplace solution. I'll get back to it also. So that's a good product. And to switch to that product, you need it to be easy. So whether you are already on Domino, Exchange, O365, Zimbra, you need to know that you can switch easily to BlueMind. We have a tool called BM Migrator to make everything easier. It helps switch the data, but also the context. This means that, for instance, if you are the chief of production and you are sharing a couple of specific calendars with your team, those calendars will be switched also with the same level of collaboration. If your secretary writes email in your name and manages your appointments, these specifics will be switched too. After the migration, you won't start from blank. You will get back to your previous context of use. We also can manage progressive migration. It happens that we switch first a test group. It can be the IT team or another specific group. Using split domain, 2 or more systems can coexist and collaborate. You can switch your IT team to BlueMind and leaving the C-levels on Microsoft, the time for you to address all the possible issues. And then when you are ready, you can switch the C-levels to BlueMind too. In the meantime, the team on BlueMind and the one on Microsoft can still work together. Last but not least, user experience. I cannot stress more how important it is. How many times we've heard at BlueMind, we want to get rid of Microsoft because it's too expensive, we feel stuck, we have no leverage over anything, but our users want Outlook, and that's not negotiable. We know how important this is, and most of the time, when we talk about open source, we are talking about deep layers of code and users will never see. But here, we are front end on the most used tool ever. So this is our tipping point. You cannot be an alternative to Microsoft if you neglect users' adoption. This is where BlueMind makes a difference. We are the only solution that can accommodate all users with a full collaborative experience. All users means native Outlook. Your user keeps the exact same Outlook, and we are the only one in the world, aside from Microsoft, obviously, to have managed that, because Outlook has a very specific language, and it took us 10 years of hard work to do it. So that's a very, very strong win. All users also means collaborative Thunderbird, Mac, webmail, mobiles, or a combination of those. The BlueMind promise is whatever your users' habit, you can accommodate them while preserving your email's digital sovereignty. Our goal is not to support the use of Outlook, but to offer a realistic alternative to the real stakes of email. And it starts with being able to make Outlook work for users. But we also have our own webmail. This is a snapshot of it. We have a full UX team dedicated to make it look and feel like a thick client. If it was all up to us, we would largely recommend using our webmail. First, the installation cost is lower as it doesn't require installation on user workstation. User can access their email accounts from any device, company computer, personal laptop, smartphone, cybercafe, whatever. It lets you manage all email settings centrally, storage capacity, usage, quotas, linked attachment, corporate email signatures, so forth. Support is also easier as you can easily replicate user settings. So this advantage is all the more significant for organizations with several sites or remote workers. All your emails are saved on the server, which means they will always be available if your device breaks down. And the webmail updates go together with mail server updates and are carried out on the server side. So it doesn't require deployment on workstations and is automatically available for all users. Time flies, so I'll get faster on the last part. So BlueMind is full API, so we can fit into your existing collaboration perimeter. Like I said first, we can be the email part of your already existing digital workplace and collaborate with all of your tools. And to conclude, what I want you to remember from this little presentation is that BlueMind is 100% API, user-centric, that's very important, cost-efficient, sovereign, and open source. So for your corporate emails, BlueMind and Microsoft is not inevitable like Thanos. You have the choice. So that's all for me. Thank you very much. I hope I was clear.
The next talk, he's eager to speak. Gergely, he's already there. He's in the starting blocks. So it is about Spare Cores. Spare Cores is it's a project that has been bootstrapped by NGI search funding. So it's one of our success stories, really. It is a platform to evaluate performance of cloud offers on the compute resources available among cloud providers. There is a lot of open data there, a lot of benchmarking run on cloud virtual machines and so on. It's impressive in terms of technical penetration. So it is you will see Gergely Daroczi, who I hope I pronounce the name correctly. For Gergely, I'm almost sure because I have trained a lot.
Thank you very much for that.
So Gergely is Hungarian, based in Hungary, and he has a strong background as a data scientist. He is the author of a book on data analysis, also many scientific articles. So he's focused on data analytics, on the data science, and also, of course, now with his company, he focuses on cloud infrastructure offerings, and he will tell you. I think his talk will be much more technical than. He's not a marketing guy; he's a technical guy. So I give you the floor, Gergely.
Thank you very much, and bonjour. Hello, everyone. I'm super grateful, Pierre-Yves, for the very, very kind introduction, also to OW2 for the opportunity to share about Spare Course, and thanks everyone for your interest and joining. So my name is Gergely Daroczi from Spare Course, and this talk will focus on how to utilize cloud compute resources in the most cost-efficient way, using our open source tools, mostly written in Python, some in TypeScript, and also some of the open license databases that we are managing. Before I get into the technical details, I wanted to share you some background stories, like why would you want to optimize your cloud resources and why it's not trivial. I've been working as a data scientist and managing teams and infrastructure in the past decade, and data science, machine learning jobs are usually bad jobs which are running a couple times a day or a week. And these might be simple as running a SQL query, which is heavy on the database, but on the client side, it's usually lightweight. Data scientist usually runs an R or Python script or something similar, which might be lightweight as well, like training a linear model or something like that, doing some API integrations. But when it comes to training or building more complex models like hierarchical models, GBMs, neural nets, and so on, it can be super heavy and require a lot of CPUs, GPUs, memories, and so on. So to keep it short, I and the team came to this idea due to problems in scaling the data science infrastructure. To give you some actual examples from past roles, here you can see a Docker container that we run, which was, I think, an R script. Here you can see the CPU usage recorded every second and also the memory usage. Here you can find that this job scaled to a single CPU. It was not able to use multiple cores, but required around 180 gigabytes of memory, so probably training a hierarchical model which cannot be parallelized. We had around 4,000 jobs like this one, some doing NLP stuff, image processing, and so on. And we try to use existing solutions like Amazon's ECS or later the AWS Batch service. And of course, Kubernetes started to become the standard a couple of years ago. We also gave it a try to use for training ML models, but it wasn't a great fit due to multiple reasons. First, data scientists needed to define the compute resource requirements like amount of CPU, memory, GPUs, and so on, which ended up in over-provisioning and some errors if the resources were defined to be low. And also, bin packing is honestly not the best solution for data science jobs. Just imagine the previously mentioned hierarchical model requires a single CPU but 200 gigs of RAM. Then you put the another job requiring GPUs on the same node. So you end up with a lot of mess and overuse resources. We solved this problem by a couple hundred lines Python script, figuring out which is the optimal server type for a given data science job within AWS. You can see here that there was a job which managed to scale to like 100 CPUs, required a couple hundred gigs of memory. So we started to start servers based on the capacity available in different regions. And once we found one, we deployed the Docker image, started the container, managed the full life cycle of that, and then decommissioned the cloud server. So again, this was a couple hundred lines of Python script, limited in many, many ways, but it was useful for a bunch of other things at the company. not only for data science, but for ETL stuff, traditional CI/CD tools like testing software, building Docker images, and so on. So we decided to generalize this a little bit. It was open source like 7 years ago under the name CloudPerf, but again, it was limited to AWS, and we were able to work on this solution only when the business needed some updates. So we were super grateful to NGI Search last year when we applied in the third call and won a grant to be able to work on a solution like this. With dedicated resources and rebrand to the next generation of CloudPerf under the name of SpareCourse that this talk is about. And I have a lot of slides. I will not get into the details. You can find the slides online at sparecourse.com, and I'm super happy to answer any questions later on, but I would like to provide a high-level overview of our components. So everything is open source on which we've worked so far, which includes database schemas, documentation on how to run our ETL tools. We actually manage an infrastructure which is running the ETL tool. We start benchmarks and everything so that you do not have to do that, like burning thousands of euros at cloud providers to see the performance of different servers. We have done that, and we have published our data in managed databases, APIs. We also provide SDKs to those APIs so that you can start using this right away without managing your own environment. We also provide some helpers so that you can easily start instances at various vendors, which is not limited to, let's say, AWS, Google, or Azure, but we support 5 vendors right now and adding others every month. And we also have a SaaS component coming up that I will share a little bit later on. A high-level overview on the data that we curate right now. This is a bit outdated. We already cover 5 vendors, which includes more than 2,000 servers across these cloud providers within more than 300 regions. We track the prices every 5 minutes, including spot instances, on-demand server prices, and so on, which adds up to almost 300,000 price records updated every 5 minutes. We also start benchmarks like Pierre-Yves mentioned previously for many different workloads. And if we check the actual scores that we generated on these servers, that comes close to like 800,000. And these are only the most recent records. If you look at the historical data that we collected over the past 10 months, it's well over 20 million records. The easiest way to get familiar or make use of this SpareCourse data is using our web component. So if you go to sparecourse.com, you can find a server listing like this one. In the left-hand side, you can find a filter or search widget, and then you can see all the servers matching your queries. If you click on a server, you get a lot of details about the selected server, including the prices, some benchmark data, like here you can see memory bandwidth of read, write, and mixed operations using various block sizes, level 1, level 2, level 3 cache amounts also included in the chart, and some other benchmarks as well, like different compression algos, OpenSSL speed, some general benchmarking frameworks like Geekbench or Passmark are also included with workloads like image processing, NLP, and so on. You can also easily compare different servers in a table like this one on the homepage. So you select a few servers, click on compare, and you can see all the tiny details, including the actual CPU model, which is often not even shared by the vendor, but because we run hardware inspection tools on the actual servers, we know about that if the hypervisor allows. We also create charts for the comparison. So here you can see the Geekbench and memory bandwidth comparison for these 4 servers. For programmatic access and computers, we provide APIs and SDKs. Here's an example of accessing server details from Python. And let me just scroll through the amount of data we capture. Like regarding the GPU, We track also the BIOS version or firmware version, which is really useful when it comes to doing some very specific workloads on the machine. So you can find all that and a lot of other details about the servers. Regarding the other components, here you can see the list of these resources, and I will try to go through some of these very, very quickly so that you get a sense what kind of open source tools we have worked on and which might be useful for your team. The crawler is the ETL component, so ingesting data, which defines the database schemas. It also actually integrates with the vendor API so that we can list the SKUs, which includes servers, regions, zones, storage types, the prices of the different storage options, traffic price, IPv4 addresses, and so on. So that's all covered within the crawler. And we also integrate with some other components so that we can pull data back into the system, like the results of the hardware inspections or benchmarks. And this is the base for other spare core components as well for the database schemas. This sounds super easy, honestly, and we hope that it would be easy. It turned out it's not. And as mentioned, I will not get into the details, but I listed a few slides, like what technical difficulties we have seen in the past. Like even just looking at the database schema, it became rather complex, and taking care of all the overlapping compound foreign keys issues or tracking the changes over time within the database record, so creating an SCD version of all the tables, or taking care of database migrations between different versions of the crawler. Like we wasted a lot of developer time on this, but of course this was useful and it needed to be done. Just wanted to highlight that it was not trivial to set up. Honestly, the most difficult thing within the crawler was the varying quality and even the availability of the data at different vendors. And to give you a quick example, like let's say I'm interested in the storage amount of a server, and AWS is pretty good with their listing, with their API, so they share a lot of data about their servers, which is pretty unique to AWS. Some other vendors do not share that amount of information. So I checked on ChatGPT if and they know about the actual storage. And you can see that this guy searched 6 different sites and actually found the right number of drives with the right storage amount, but doing the multiplication just failed. So there's hope that spare cores is still useful. Looking for that data actually requires a lot of data cleaning and curation and so on. To give you some examples, like if you're looking for the storage amount for a server, there are some vendors which do not share that with the API. We have to parse from the server description if there's an SSD within the server, or CPU info hypervisor is not provided. We have to fetch that data from or crawl that from the web page and so on. To give you an even simpler example, if I say EU West 1, that probably rings a bell if you have used AWS before. That stands for a region within Ireland, but sometimes it's called EU Ireland. So we already have 3 different names for the same thing. And actually the AWS API requires you to sometimes use either the alias or the ID and so on. So it's really confusing. We standardized everything within our database schema so that you always know what to use. We provided a standardized display name for all the regions across different vendors, and we enriched the data with the exact location, the energy source. For example, if it provides, I mean, all the servers are running in that region by green energy. We track compliance framework, like you're looking for some servers with HIPAA or SOC 2 certificates and so on. You can easily do that. And I will not get into the details of this one, but Figuring out the price of a server is not easy at many vendors. It's not like you go to the homepage and you see that for this machine you pay this amount per hour, but some guys out there requires you to do some basic math operations for this, like you count the CPUs and then you multiply that with the server family specific core price per hour. You do the same for memory and so on. But to make it more complex, the server family is not even provided as a structured data. So there's a lot of things to be done in the background. Great news is that we have done this task for you. So you can find SQLite file database dumps on our homepage. You can download it. It's in a clean and standardized format, and you do not need to bother with all the problems that I shared previously. The easiest way to do so, instead of just downloading the SQLite file, if you're using Python, you can import our SC data package, which is updated every 5 minutes. And actually, if you use this Python package, there will be a background thread updating your local SQLite database every 10 minutes automatically. Here you can see some stats about this, but to keep it short, there's tons of data about the cloud servers that we collected and we generated. The inspector component is yet another Python package which provides hardware inspection tools on the servers running like LSCPU, NVIDIA SMI, and a few other things, and a bunch of different benchmarking workloads as well. And we continuously add new ones. Like most recently, we got interested in looking at LLM inference speed that we want to run on all the servers using both CPUs and GPUs and some other ML models as well, like GBM implementations and so on. This is hosted in a Git repo and hosted on GitHub. So if you're interested in the raw data, you can just go there. The raw output of the benchmarks is recorded in that repo. There's like hundreds of thousands of commits so far. If you're interested in the structured data, then you can use our SQLite file. But I want to emphasize that everything we do is running in public using GitHub Actions for transparency and also for reproducibility as well. If you want to run this stuff on your own server, laptop, or whatever, to have a baseline for the benchmarks, you can do that very easily by using our Docker image. You can find that on GitHub as well. We have the runner component, which takes care of starting machines. We are using Pulumi in the background, which is similar to Terraform, so infrastructure as code. But with Pulumi, you do not have to learn yet another language like HCL, but you can use Python or TypeScript to define your cloud requirements. We are using this tool in the background by creating Pulumi templates, and we have this standardized CLI tool so that you can start machines at any vendor that we support. So starting a machine and then destroying it within AWS, GCP, Azure, Hetzner, UpCloud, it's just a change in the subcommand, and we take care of the rest. Just some fun facts regarding what issues we have faced in the past. When you create a new vendor account, usually you get a lot of quotas. And the big ones, the hyperscalers, are super strict about that. Like at AWS, we needed access to the big machines so that we can benchmark the GPUs and all the big machines, and we run into issues with getting approved for that. At some vendor, it took 3 months to get access to all their servers, including dozens of support tickets, back and forths, phone calls, and so on. And even though we have access to like 20,000 euros of credits right now at a vendor, we were not allow listed for some machines because of capacity and other issues. Anyway, the related fun fact is that once we opened a quota update request, we actually hit a quota update request quota that I found pretty hilarious. And I know running out of time, so I will keep it super short regarding the other components. We have an API which is publicly hosted. You can use it for free. You can also host it if you wish. we have the web component that I shared previously. Please go to sparecourse.com. We have this fun slot machine. You just enter the number of CPUs and memory, hit spin, and you get the cheapest machine. Of course, if you're interested in more details, I would rather suggest looking at our tables. I will skip the future plans because of time constraints, but super happy to share offline more if there's interest. But wanted to thank the team for working on this. I'm in a good company, as you can see from the profile pictures. And we have Attila who's taking care of most of the infrastructure stuff, and Balu, who is the front-end person creating all our cool web widgets. And I'm super grateful to NGI Search, which actually made this whole project viable as we applied last year, got funded, and we managed to spend the past 10 months collecting and standardizing this data and coming up with these components to share. So I know time is up, so I will stop right now, but please visit our homepage and reach out if there's any questions. And thank you very much again.
So concerning the coming events, if you want to meet us, we will be present as almost everyone in the FOSS community at FOSDEM in Brussels. And you will probably meet us close to the NLNet booth, because we work with them on AGI Zero Commons, and that's what we push ahead currently. And there are also two events that we organize or that we co-organize for the first one. So the first one is a local, a small event, but a local one in France, which is called Alpos. It's hosted by the city of Échirolles, close to Grenoble. So for the French open source ecosystem, Échirolles is a well-known place because they are really focused on open source at the city hall. And the other one is OW2Con, so ow2con.org. It's in Paris. It's hosted by Orange at their Orange Gardens Innovation Center, and it's in June 17th and 18th. And of course, all these events are free, so you are welcome to join. Thank you very much.